So hey guys, we will learn about what is system design. We will learn from the basic concepts. Okay? The system design is the process of defining the elements of a system as well as their interactions and relationships in order to satisfy set of specified requirements. It involves taking a problem statement, breaking it down into smaller components, and designing each component to work together effectively to achieve the overall goal of the system. This process typically includes analyzing the current system and determining any deficiencies, creating a detailed plan for the new system, the testing design and testing the design to ensure that it meets the requirement. It's an iterative process and may involve multiple rounds of design and testing. So what is system design? Basically, you design a system, right? You have a problem, right? You have a problem. You need to solve it. You need to solve it using some hardware or software or whatever architecture you build, right? Architecture you build. And this architecture that you build is a system design. Okay. So this is a system design. So you have to arrange all the components in such a way that it solves the problem that we have. Not code wise, but the architectural problems. So that's what a system design is. What architecture or what services we will use. It should be arranged in a proper way. So it gives the maximum output and solves maximum problems. Okay. It is also an important aspect of the interview process for software engineers. Most of the companies have a dedicated system design interview round. So if you are a senior developer, of course, system design is the must-have topic where they ask the candidates are expected to come up with a detailed design of the system, including the architecture components and their interaction. You should know various kind of what do we say this definitions like throughput or latency, performance, scalability, availability, or consistency patterns. So this type of topics you should be aware of in system design, right? So this was about system design. How to approach system design. Second topic is how do we approach a system design. So first understand the problem, right? So first understand the problem. So whatever problem we have, you have to understand it and you have to make sure you gather enough information about the problem you are trying to solve and the problem and the requirements of the systems. Identify the users and their needs as well as any constraints or limitations of the system, right? So first understand the problem. Second is what do we do? Identify the scope of the system, define boundaries of the system, right? What are the boundaries? Like how many users can it is scale up to, like 10 million or 30 million or whatever user base can be there. Third is research and analyze existing system. So try to find alternatives if already there are this type of systems or apps, and what are how study them. Basically study them, right? Study those systems. Fourth is create a high level design. So high level design means create a high level design. So first just try to create a upper level design, also known as high level design. So try to create that. So from upper level, just try to create that this will be the service, this will be second service, one, two, this both will communicate. How will the transaction be taking place in the DB? So just a high level design, not we won't be going in deep here. So fifth is what refine the design. Now, as you have created a high level design, you can refine that design and add more details. Refine the design. Okay, just refine it. Sixth is what document the design. Document the design, documentation of your design for future reference. So just have a screenshot. That what I would say. Have a screenshot of whatever you have prepared and have it in a folder of your app. Have in folder, and that folder name should be your whatever your app name is, right? Seventh is continuously monitor and improve system, right? Continuous development or improvement of the system. Okay, so this is how to we approach system design. So how to system design, right? To approach system design. Okay, so these are the steps. First, I understand the problem, check the scalability, check alternatives. If there are already some alternatives in the market, study their system design. High level design, prepare a high level design, refine that design, have a screenshot of that design, continue development, and as you know more and more concept, try to improve that system because that will help, right? So remember these steps. These are very important actually, right? Now that was all about introduction. Now performance and scalability. Performance versus scalability. What is performance and what is scalability, right? So let me just write performance versus scalability. What is performance and what is scalability? So a service is scalable if it results in increased performance in a manner proportional to resources added, right? So what happens? Generally, increasing performance means serving more units of work, but it can also be to handle larger unit of work, and such as when data sets grow, right? So what we will do, like scalability, you know, right? How we can scale if we have one service, right? We can duplicate that service. We can duplicate once again and make it scalable. Then we can have a load balancer. It can distribute the load. That's how the scalability works, right? We can scale our system. Now performance. As we scale the system, the performance will go up, right? If it's scaled properly, right? So if you have performance problem, your system is slow for a single user. Another way to look performance versus scalability is if you have a performance problem, if your performance is not good, your CPU is not providing a good performance. So what it means is for any single user, your performance is very slow. And if you have a scalability problem, your system is fast for a single user but slow and under heavy load. So that's a scalability problem, right? You have to scale. So what it means, if there are 100 users, right? Your system works fine. If there are 1,000 users, your system lags. So this is where you can scale your system. That's a scalability problem. You have to scale it. Performance is basically your CPUs which go high. So that's a code issue. I think you have to optimize your code, right? So optimize your code optimization. Okay. So that was about performance versus scalability. Now comes latency versus throughput. Now let me go down. This is a crash course sort of thing, so that's why I'm going a little faster. Now let's go with latency versus throughput, right? What is latency and what is throughput? So latency and throughput are two important measures of system performance. Latency refers to the amount of time it takes for a system to respond to a request, right? So this is about whenever request comes in to the server, of course. So latency refers to the time it takes for a system to respond to a request. So this request comes to the server, okay, and how much time this will take to respond back. So this time that it takes to respond back is latency. Okay, server will of course go to the DB, or it will query the DB, it will query the database, and what other things it can do. Let me just check if it's recording. Yeah, it's recording, then fine. Okay, so all other things, query the DB, it will go to some third services and make some adjustment, or it will call AI models or whatever, right? So whatever time, let's say 3 seconds it takes, that is what latency is. Throughput refers to the number of requests that a system can handle at the same time. So what is throughput? Throughput is like, let's suppose there is user 1, U1, U2, U3, U4. They all made a request to the same system, right? This is the server, and they made this is R1, R2, R3, R4. So how many requests simultaneously it can cater, right? How many like requests at same time it can cater. So that is what throughput of the server is. Generally, you should aim for maximal throughput and acceptable latency. So latency should always be low and the throughput should always be high, because we need our system to cater as many requests at same time as it can, and with the minimal latency. So that is what throughput versus latency is. Now let's go with availability versus consistency. Right? These are some of the great topics, I would say. Availability versus consistency. The difference between them, right? Availability refers to the ability of a system to provide its services to clients even in the presence of failures. Right? What is availability? So even if your system gets failed, your even your system get failed, it should be available to the users. Fail in the sense, even if one node gets failed, other node should be up, right? So that is what availability is. This is often measured in terms of the percentage of time that the system is up and running, also known as its uptime. So you might this is also known as uptime, right? So you might know this. I have also worked on one of the project that I would like to show, but I think it's not live, but there is this uptime, you see uptime.betastack.com. So this is the website. If you see, let me go. It's by Betastack asking for sign in. But uptime.betterselect.com is around how much your uptime or website is available. So that is a good way to calculate your uptime or availability. And now what is consistency? Consistency, on the other hand, refers to the property that all the clients see the same data at the same time, right? So data consistency, this is about data consistency. So in this now, what you can, the prime example of this is transactions, right? Transactions, ATM transactions or currency transactions or the money deducted from your account that should reflect a same amount. If I fetch it from PhonePe or PayPal or let's say Paytm or Google Pay. So it should reflect the same amount. So that is what data consistency. Your data should be consistent wherever it gets fetched from, right? So in distributed system, it is often a trade-off between availability and consistency. So sometimes what happen now, if we want a consistent data, right? So we need some time to make it consistent, right? We need some time to query the DB, to query DB or to make changes in the DB, and that will take some time, right, to make changes. And if there are multiple copies of DB, like master slave architecture, then it's another scenario. Then we need to make sure that all slaves are updated, right? Because there might be some servers that will be pulling data from those slaves, right? So trade-off between availability and consistency. System that prioritize high availability may sacrifice consistency, right? And some system that prioritize consistency may sacrifice availability, because though both cannot go hand in hand, because as I said this example, right, DB changes and all, it cannot go hand in hand. But in future, who knows, there might be some solutions which adjust both, right? Different distributed systems use different approaches to balance the trade-off between availability and consistency, such as using replication and consensus algorithm. So consensus algorithm we'll learn later. Later we will learn about it. So that was about availability versus consistency. So there is this CAP theorem. Okay, what is a CAP theorem? Okay, CAP theorem. We have to learn about this. So CAP theorem is let me just write the topic first, which is CAP CAP theorem. Okay. So according to CAP theorem, in a distributed system, you can only support two of the following guarantees. Consistency, every read receives the most recent write or an error. Okay. So first is consistency. So every read we receive, it is the most recent write. So whatever read request that we receive, what we will be giving, what response we will be giving is the recent right, recent write or an or error if you don't have anything, right? And availability, second is availability. For the availability, every request receives a response without guarantee that it contains the most recent version of the information, right? So if we cannot, wait a second, cannot guarantee if info is the most recent version, right? Availability, sorry, the consistency is done, availability is done. Now third is what? Partition tolerance. Partition tolerance. So what is partition? The system continues to operate despite arbitrary partitioning due to network failures. So system continues to operate despite arbitrary partitioning due to network failures. Networks, even network, so partition tolerance means we have some data on, what do we say, data on caching, right? So that data we continue to serve until there are some network failures, right? So the partition tolerance. Now networks aren't reliable, so you will need to support partition tolerance. You will need to make software trade-off between consistency and availability, right? Now CP, consistency and partition tolerance. So this can be matched with this, and this can be matched with this, but not both, right? So let's see first, which is CP, which is consistency and partition tolerance. Let me first pause this video and check if